Hello and welcome to the final presentation of the Omdena Liverpool chapter project detecting paediatric acute lymphoblastic leukemia using computer vision. Now, why did we do it? Why have we picked this topic? In developing countries, tests like flow cytometry are not only expensive, they're also hard to source. We don't have a problem in the developed world getting tests like this, which can readily diagnose this type of leukemia. The diagnosis can be time consuming. It's very difficult if you don't have, cytometry to diagnose these kind of things using vision alone, like someone taking slides and looking down a microscope. They have to be accurate. They have to, have people with those particular abilities at hand, which is not always possible. And, so what we try to do is build a time and cost efficient system that could aid oncologists with the diagnosis of this disease and fundamentally attempt to save a lot of children's lives. The data that we used, as you can see, are images of single cells. It was collected from the Cancer Imaging Archive, and I have linked the main paper. Now, the data comes from 2019, so it's quite recent. It does have around 15,000 images from 118 different patients, and it has been split into two classes, ALL and HEM. HEM is to indicate that the cell is normal, and ALL indicates that it is a leukemic blast. Now, within this data set, there is a validation set, and it has the ground truth labels, which have been labeled by an expert oncologist as well. So what did we do, and how does it work? Now, the team created a web app that was able to discern whether a cell was leukemic or not. And we did this by using a pre-trained model, which extracted the features of the cell image. And then we deployed a sort of traditional machine learning algorithm to classify the cells. The web app basically allows anyone to use it. It allows easy deployment in a hospital or a lab within the developing world. All you need is a laptop or a phone. And allow me just to demonstrate a little demo video. So what basically happens is you're able to use a image of a cell, upload it, and then it populates these raw image sections, and it pre-processes that image as well, as you can see here. And then from that, we can click this button to extract the features, and our pre-trained model extracts all the information about that feature and puts it into a data frame. And from that data frame, we can use a traditional classifier to classify the image. And in this case, it comes up with a HEM, which is a normal cell, which is absolutely correct. As you can see, our web app, it's quick and it's efficient. And we basically were able to use our model to classify leukemic blasts with an accuracy of 90%. Now, this is a fantastic result, despite the sort of time constraints we had and the limited time for experimentation we had as well. So what did we learn, and what is next? The team learned how to use pre-trained models to extract image feature for analysis and prediction. And we also learned how to build experiments manually, as well as using experimental tools like Optuna, which is a fantastic package. Now, as I mentioned a couple of moments ago, our time frame was quite limited. So what we could do to expand this particular topic, or this particular project rather, is we could experiment with different types of pre-trained models. We only used VGG16 and ResNets. However, there are many different kinds of models we can use. Some may, significantly outperform what we already did. And also we can look at experimenting with building our own custom convolutional neural network to see if we can do any better than the pre-trained models that are available. Now, this project couldn't have been done without our collaborators. And as you can see, we did have a number of very active members who both their experience and expertise and imagination contributed many things to our project and made it an absolute pleasure for a project lead to host such a great project. I'd like to give a special thank you to Oase, who was the principal machine learning engineer, and he did a fantastic job in organizing the team, collating all their ideas, collating all the experiments that people were doing, and trying to give equal weight to everyone's ideas and suggestions. It was an absolute pleasure to work with each and every one of you, and I wish you all the success in the future. Thank you very much.